So if we label the forces on this diagram, how many forces are there? What's a force? Gravity. Where does that act from? So it does say from the points of application. So where does the force of gravity act? At the center of mass. So we have at the center of mass, mg down. What other force exists? Normal force. Where does that? Right at the surface. At point P. What friction? Where does friction act? At point P. And what direction? What direction is it going to roll? Angularly. So what direction must friction be? The direction of rotation. If there was no friction, it would slide down the ramp, so the friction has to be up the ramp. Okay? Because that's going to cause the torque that causes it to rotate in the logical direction, right? It has to be up the ramp again. If it tries to slide down, so the friction has to be up. So there's the three forces. Now, the next part is, and that's the only part I copied since it's relating to this chapter, is calculate the force due to friction acting on the ball as it rolls along the roof. Okay, so this is the basic problem for an object rolling down a ramp. Nice thing is, it is kind of the process that we used before. All right, so what are we going to do first? After we draw the diagram, sorry. Sum up all the forces. In which direction? Both the x and y and the rotational. So if we write out our equations for the linear motion, and of course there's the angle theta at that location. I know it's off the map here. So let's write up our linear forces. So we have in the direction of the ramp, mg sine of theta minus the frictional force is equal to the mass times the acceleration. In the y direction, we have the normal force is going to equal the y component of gravity. Thank you. Thank you. And then in the rotational direction, what do we have? I'll leave that one up to you. Say it again. I, which is okay. So when I have all those three equations, I'm trying to find the frictional force. We have two unknowns. Actually, we have three unknowns. Bless you. We don't know the linear acceleration, we don't know the frictional force, and we don't know the angular acceleration. So what would be one of the first substitutions we can make? Acceleration with what? We replace angular acceleration with a over r. Now that r cancels one of those, and then the r here will cancel the other one. So we have 2/5 m times the acceleration is the frictional force. We still have two unknowns. So we have, out of the three equations, still have two really unknown quantities, which is the frictional force and the A. So we have to combine the equations to solve for friction. Good. So we're going to take this and plug it into here. All right? So we have mg sine theta minus 2/5 A equals ma. We move this over. So that A is equal to 5/7 g sine theta. After we solve for A, again, same process that we used before. Combine everything, solve for A, then we plug A back in. Now we're going to plug that in to here, because we're looking for friction. So we have mg sine theta, and I'm going to move them around. M times A Sorry, struggled on my math there. Almost added instead of subtracted again. All right, so there we get the value of that frictional force from this. Okay? Same process that we were using before. Yes? I'm sure there's multiple substitutions that you could have made. All right?